Hello, everyone. Thank you and welcome for joining us for this webinar. Sorry for the delay. We were waiting a couple of minutes for more people to join. Uh, so just to mention that this webinar is recorded, but we will stop recording once the Q&A starts. Right. So I will be presenting the webinar, and then in a at the end, so when Q&A starts, we will stop the recording. So my name is Nima. I'm a postdoctoral fellow in Trinity College Dublin. Uh, I'm funded by Irish Research Council as a part of the Government of Ireland postdoctoral fellowship scheme. Uh, so I did my PhD in Trinity College from 2016 to 2020, and then I've been since a postdoctoral fellow and vice chair of Hyperledger Telecom, a special interest group. So, if you remember when you registered, there were a few questions on the registration page. We were trying to figure out what is the level of kind of that people know about blockchain that are joining this webinar. Realized that most of the people are familiar with the basic concepts, but it would be a good idea to give a brief introduction into blockchain. So to us, really, it's all about how you store data, right? So in traditional database systems, everything was centralized. So you had one server who stores all the data, and then you have multiple clients that join, kind of try to connect to that server and get the data from them. But because that was exposing these systems into single points of failure and other issues connected to that, the industry has moved towards distributed databases, in which you have multiple copies of the database stored in different servers, and then these servers, using some techniques, are kept in synchronization all the time, so the data is the same on the both servers. So distributed ledgers, on the other side, are kind of a similar idea as distributed databases with a number of differences. So you still have multiple copies of the database on different servers, but the first difference is that with databases, with uh, databases like the famous ones, the distributed databases, you have multiple options as to what you can do with the data. So that includes creating a field of data, reading some data, updating data, and deleting the data. But when it comes to distributed ledgers or ledgers in general, you only have read and write access to the data, which means that you can only append the database or append the ledger that you have. And on top of that, instead of tables in that we have in databases, we have chain of blocks that are connected through hashes, and that makes them immutable. Uh, and then when we come to blockchain, it's essentially a collection of technologies that enables secure, transparent, and reliable operation of the distributed ledger. So these are a collection of tools that actually make possible doing what we want to do with the distributed ledgers. Uh, on the next note, so we have smart contracts. So what distributed ledgers do with data, essentially smart contracts do with agreements and contracts, meaning that instead of one party, one central authority taking care of everything related to the data, here you have multiple people or multiple organizations doing what one person used to do before. Meaning that if you have a if and else clause in an agreement, in a contract, you can write it as a piece of code called the smart contract, and a collective of the participants in the network would kind of have to sign the outcome of the contract, of the execution of the contract, so it will be written on the ledger. Another confusing really subject is the difference between public-private permission and permissionless blockchains. So this, the most simple way of putting it is essentially these are related to read and write access to the distributed ledger or the database, right? So in public blockchains, everyone can read from the blockchain. In private blockchains, a handful of or a group of people only are allowed to, only authorized people are allowed to read from the database. The same thing applies for permissionless and permission blockchains, where it's about writing kind of access. So where you have in permissionless blockchains, everyone can write on the blockchain, and in permission blockchains, only a limited people, a number of people can write on the blockchain. And that has really implications on the scalability of blockchains. We will see more about them later on. But essentially, the public blockchains that we know, Ethereum and Bitcoin, for example, are public permission blockchains, permissionless blockchains, which means that everyone can read from them and also everyone can write on them, proven that they have contributed to the consensus protocol, right? But it's not the same for example, for private and permission blockchains, which are going to be the main focus on this talk because they're really more compatible with the requirements that we have in telecommunications industry or so on. So that being said, just one other concept that we will talk about before jumping into the details of the talk is really the concept of trust and how we define it here, just to be on the same page. So these are famous Alice and Bob. So Alice and Bob, if they want to do some sort of transaction between themselves, Alice would have two reasons not to trust Bob. So one reason is that Bob might want to manipulate uh, the data or the execution of that agreement to gain economic or political kind of advantages uh, against Alice. So it has like economic and political incentives to cheat. And also Alice might trust Bob in that sense, but it just might not trust it enough to be competent enough to keep the data and the network secure, right? So these just these were the two concepts that I wanted to mention here. So they both apply when we talk about trust in blockchain-based systems. Uh, you might have noticed the beyond the hype in the title, and that's really I couldn't find a better way to describe the hype around blockchains than this website. So if you have your mobile phone handy, just try to open this website. Uh, it's an interesting, well, kind of a joke, but uh, you can essentially generate put together random words and generate blockchain projects. So I'll read some of the ones that I generated here. The words first: decentralized bike lending platform for Lambo owners, the first smartphone operating system built on blockchain for vegan butchers, and so on. So they might sound silly, but then I generated some of them that actually made sense. Some of them made more sense than my own projects. The convenient platform for secure decentralized applications or integrated app monetization ecosystem for finance industry based on blockchain. So you can see uh, you can actually generate random names and random sentences, and they would make sense as a blockchain project. And the reason really there is that blockchain as a technology is similar to the database technology, right? With added features. And you can't really think of any industry at the moment that doesn't use databases, doesn't use data, and doesn't have concerns around data privacy and security, right? So that's really the reason in my mind for the hype around it. So what we will do in the remainder of this talk is that we will look into really why this hype exists and the challenges around the thing the concepts related to blockchain. So this is kind of a looking. So the slides we'll see is both for blockchain applications for networks and also networks for blockchain. So this slide really kind of was my way of categorizing everything that is out there about blockchain. So I put them in different layers. So the first layer is the layer of use cases, and really the idea here is that we have all these smart communities, uh, and the idea there is that they all have concerns around trust within themselves, and also when they want to get connected in a broader area. Let's say in a smart road kind of initiative might want to talk to the smart energy community and so on. So the idea is to look at the bigger picture here and try to bring that trust to connected communities, right? And really the beneficiaries here would be the energy authorities, the local governments, and similar areas. So really the challenge here is that when these communities want to talk to each other, with the current situation in the blockchain kind of ecosystem, is that each one of these smart communities might be using their own version of blockchain, which could be very different to the other version that the other community is using. So interoperability becomes a very important issue, and there are solutions including, well, the standardization of the blockchains. So ITU is really undertaking the biggest and the international effort to standardize blockchains. So ITU must be a kind of a familiar name for the people in telecoms. And they're trying to push this ISO standard TC 307 around blockchain as distributed ledgers. So they're trying to define the terminology there and also define the interfaces that could be needed there to kind of have an interoperable blockchain ecosystem. The other the other solution to the interoperability problem seems to be the common infrastructures that are out there. So one of them is, and I guess the most successful one is the European Blockchain Service Infrastructure, EBSI, that has multiple nodes in different European states, and you can essentially join as one of the EU states or a representative and connect the nodes that they have. Currently, they support Hyperledger Fabric and Ethereum, if I'm not mistaken. So you can join this network, and the idea is really to provide that common infrastructure that could be used for kind of bigger ideas when deploying blockchain solutions. Currently, they have some use cases defined. The use cases are not telecom related, but uh, they're open to new use cases. So we can actually collaborate and come up with new use cases for the EBSI blockchain. And there are also some other academic solutions to the interoperability problems that includes blockchain of blockchains and so on. We won't really go into detail of them, but this is one of the important issues in the blockchain area. The other layer is the application layer. So you can see here that we have the distributed identity application that is very useful for eSIM cards, for data privacy, smart vehicles. So the idea here is to kind of try to provide, in addition to providing a distributed and decentralized identity management system, is to kind of give back some control to the owner, to the people who own that identity, uh, and it goes really towards the self-sovereign identity, that I have control over the amount of data I want to provide to someone who's trying to identify me, right? Uh, is a very interesting kind of ideas around this. Uh, the other area is the contract enforcement. So this area really uses the smart contracts to assure solving problems in terms of kind of enforcing service level agreements or any other kinds of agreements, including quality of service agreements, for example. So if two operators are trying to kind of one operator is trying to serve another operator with certain amount of infrastructure, they should be able to, without any third parties, they should be able to solve their problems between themselves. So and talking to some of the operators, we've realized that they have issues around sometimes they cannot come to an agreement over, let's say, the measurements that have been taken place. So imagine two operators not being able to agree upon the measurements that they had, let's say, around availability of the service, and that causes issues, and that delays really the reconciliation and settlement of these issues. But if you have that written as a piece of code, very simple if and else, and immutable, or if you had those measurement endpoints connected to this smart contract that would just immediately send the data, things would be very more simple. The other area is the distributed marketplaces. We'll talk a little bit more about this because this has been really the main focus of Connect Center around the area of blockchain, our team here. Uh, the other area is the fraud prevention. Uh, that includes SDN security. So what we've done with SDN in the past decade really has been trying to centralize most of these control functions within the networks. But now we start to realize that maybe some decentralization is needed there. So a very simple example of that is, let's say, just keeping the records of all the DDoS blacklist IPs on a distributed database rather than, on a distributed blockchain rather than on a central database. Or more sophisticated use cases such as having incentivizing different network nodes to share their attack data using smart contracts and blockchain. The other area is the equipment supply chain. That's also quite interesting, the way some companies are trying to make sure no manipulated network equipment is making it into their systems by using smart contracts and blockchain technology. So the challenge usually with these use cases is that, so they have a very wide range of requirements, right? So some of them require massive scales. So let's say IoT or vehicle to vehicle networks, communication networks. So you might have thousands, tens of thousands, or hundreds of thousands of devices trying to communicate over this blockchain network. So that's one of the scalability factors and aspects. The other dimension is throughput. So currently, most of the blockchain frameworks cannot even compete or get even close to what, let's say, financial transaction systems can support. So we're looking at applications with thousands and thousands of transactions per second. That is not possible at the moment on most of the blockchains. The other dimension is the latency. With 5G and next generations of mobile networks, we know that, so some of well still some of the applications could be even not really real time, or we could tolerate minutes for latency, but with some of the use cases, we will have to provide milliseconds or microseconds level of latency. Uh, so as I mentioned, most of the current architectures of blockchains cannot support this, especially in the area of IoT. And really new architectures seem to be the way to go to address these scalability issues. So one of them is hierarchical blockchains, where you have really kind of some sub blockchains connected to a global blockchain. So these local blockchains will then communicate with the main blockchain on a periodical basis and send the data and synchronize the data in a time to time basis. But then the essentially the local or the edge blockchains will be closer to the IoT devices, and also would have less kind of burden on them to process. The other idea, kind of similar, but also with differences, is sharding. So sharding is essentially kind of dividing the task of validating the transactions on the blockchain to smaller chains. So you'll have multiple chains, and each one of these multiple chains will have a certain number of nodes taking care of verification of the blocks and so on. So these are the solutions in that area. Uh, so looking at all these use cases, so these use cases in general, any blockchain application is a piece of software, and it requires infrastructure to run upon. Uh, and the way it seems, the cloud is mainly the way to go, but there are other options as well. So an estimate says that blockchain as a service market is to hit 20 around $25 billion by 2027, and it's only understandable that all the major cloud providers are now trying to compete for this market. They're offering different services. So the main one seems to be blockchain as a service, where the cloud providers provide both the software of the blockchain, which is usually based on a customized versions of open source blockchains, and at the same time the cloud resources required for it. So the advantage here is that it's very easy to set up. You don't really need any blockchain knowledge to go and set up these blockchain solutions. But the criticism that has been around this has been that, okay, so we tried to decentralize everything, but now we are going to rely again on one platform and one let's say cloud provider to take care of everything around the blockchain. And they often have limited blockchain governance kind of access also for the people who are trying to use that. The other option is infrastructure as a service, which is kind of a little bit more hassle to set up. Well, they don't offer you the software, so they just give you the cloud resources required for it. And the other option is on premises, so you can have your own servers, and essentially you'll have the freedom of setting up your own blockchain platform, and at the same time having absolute control over the resources. So the idea here is really to kind of find a solution where allows hybrid cloud, on premises, and also multi-cloud environments. The issue here with the infrastructure is that most of the current blockchains have sustainability and cost issues, right? And that is mainly due to the consensus protocol that they use. So most of the well-known cryptocurrency blockchains use consensus protocols such as proof of work or proof of stake. And the reason there really is that they have all anonymous or pseudo-anonymous users, and they cannot really rely on, let's say, if someone tried to cheat on the blockchain, you cannot really track them down and keep them accountable, hold them accountable. But then when we come to more kind of enterprise blockchain areas, you don't really have that issue because you know that in that consortium that you have, so these people know each other essentially. So these organizations know each other, and you can hold them accountable. So you don't really need such level of kind of trust to be acquired with your consensus protocol. So you can go with some other consensus protocols that are kind of older and has been around, kind of older with the distributed system concepts and so on. So one example of that is Raft, which is based on kind of electing leader and leaders and having followers to kind of the leader and follower model, and they're way more efficient than uh, kind of the proof of work or proof of stake, I guess. So essentially, these new consensus protocols seem to be the hope for improving the sustainability and reducing the cost of blockchains. The other idea is well, the other layer is the hardware and storage layer, where kind of comes down really to what is required to run these kind of blockchain solutions. So in some of the use cases, for example, for the in the distributed identity solution, you have certain amount of data that is not they're non-transactional data, right? That includes PDFs, pictures, or personal information, and as we know, as we described before, in blockchains, you just add upon data to kind of build your storage, right? So you cannot really delete anything, first of all, and also you just keep your storage requirements keep growing because you just keep adding data. And you really have two really good reasons to keep this data, keep big data, bigger data than just text data, transaction data off the blockchain. So one example is that you want to reduce the burden on your blockchain, which would increase again the performance of your blockchain and reduce the cost, and also to comply with data regulations. So there are multiple regulations. So some countries have regulation that you are not supposed to keep the personal data of the citizens outside the borders, or also you want to be able to uh, kind of delete some data that could be criminal data, right? So off-chain storage seems to be really the answer there. And one version that is becoming very popular at the moment is IPFS, interplanetary file systems, which offer a distributed alternative to keeping these kind of data, non-transaction data, off the blockchain, but at the same time in a distributed manner. The other area related to hardware and storage is, well, as you can see, kind of all industries are trying to gain some parts of this market. And for example, Xilinx has optimized hardware structure for running blockchain systems. So they're trying to improve the performance of Hyperledger Fabric using hardware acceleration. So that's one user. So they're developing certain libraries, specific libraries for Hyperledger Fabric. The other area is the other example is a collaboration between IBM and Intel, where they're trying to bring that private chain code idea into the hardware. So they're using the trusted execution environment on Intel SGX series to kind of bring that layer, if bring the trust even to a layer down into the hardware. So these chain codes, these well smart contracts would run on the hardware and kind of very secure. So that was really kind of a state of the art, really on what is happening outside about on the area of blockchain, and also kind of what are the challenges. So we'll now just give some of the example work that we've been doing in Connect Center really around blockchain. So the first thing has been the automations about self-enforcing smart contracts. Uh, as most people would know, on this in this webinar, uh, secondary resource sharing is 5G is becoming very important because as demand grows for infrastructure and development of infrastructure, deployment of infrastructure is not able to keep up with the requirement of the infrastructure. Everyone is trying to make sure that they're making the best use of their resources. So that applies to radio spectrum, 5G network slicing, and optical access networks, where you want to create a marketplace where you allow all these entities to share their idle resources with other operators or other service providers. And we did this work really. So this is the work that we did in the area of slice brokering. So traditionally, you had the idea of having a broker, a central broker, who is going to kind of run the market mechanism, which is going to determine who gets how much of the idle bandwidth for what price. Uh, and this could be any market mechanism. Here in our case, it was a double auction. So our idea was to take out this centralized auction and kind of create it as a smart contract on the Hyperledger Fabric network, where all the operators or service providers involved in this process of trading will get to sign on the kind of validity of execution of this market mechanism, and then they will send it back to the blockchain, and then the verification phases will happen, and we can make sure that no cheating could really happen, and consequently all the operators will have incentives to participate in this marketplace. So this is a sneak peek really into our tool stack that we're running our experiments on. So we have all these VMs, and each VM is essentially a machine on the public cloud, and we really try to mimic the real blockchain by trying different by putting these VMs in different geographical regions and so on, to make sure that we really reflect the true latencies. And this is really just briefly talking about what are the kinds of experiments that we try to do there. Uh, so what we try to do is to make sure that the solutions that we're offering are going to be scalable enough for the real network. So, for example, here we try to kind of measure the latency of this auctioning happening on the blockchain by increasing the load of the transactions, meaning that we start from 20 transactions per second up to 120, and we measure the latency uh, along the way, and we can see that we achieved more than 120 transactions per second with a latency lower than 1 second, and these values are quite sufficient for use case such as 5G slicing, for example. So that means that in under 1 second you can do this auction over the blockchain and kind of return the results to the orchestrator, for example, in your 5G system. In the right hand side, then you see kind of a more recent work that we've done, and there we were really trying to more look into the systems that we will require, the amount of cloud resources, for example, we require, and how we can actually kind of increase these kind of improve the results that we get, the throughput, for example, or reduce the latency by putting in more resources into it. And we kind of did also a cost estimation here to see really what is going to be the cost of running these sort of applications in a higher scale. And our results here were a bit better because we had access to more resources. So we got up to 400 transactions per second with around 1 second of latency. And here, just briefly, we're trying to mention the Open Ireland testbed that got recently funded by €2 million, and the idea here is to really kind of build that end-to-end testbed with open systems and also open source software, which is very relevant to the work that we are doing with blockchain. So this is really going to give us the opportunity to kind of get out of that, just kind of having the VMs and to run the experiments on, and we can actually take out those experiments and connect them to real wireless equipment, kind of slicing orchestrators and so on, and do kind of a wider experiments. Another, well, the time is a little bit tight, but so the other range of use cases that we have been working on, kind of with collaboration with others, has been the distributed identity idea. So this is the most recent solution brief, the white paper we've published with Hyperledger Telecom, special interest group, and in collaboration with IBM. So the idea here was to really see what are the requirements for a decentralized ID and access management solution based on blockchain, and in particular Hyperledger Fabric. We tried to kind of see how a blockchain solution would fit into the telecom ecosystem, and how that would fit in with the IoT infrastructure that we're going to have. And also we try to kind of suggest this as reference architecture for such use cases. More importantly, we tried to come up with the really the kinds of transactions that will happen on in such applications, right? So initially would be issuing an identity or changing something in the identity. So these are all kind of the different types of transactions that could happen. So we try to discover what are those transactions and who would be the participants really in those transactions. The other area was the key assets that we tried to define there. Really, what would be again involved in a distributed identity solution based on Hyperledger Fabric. Uh, this is an older work again with the Hyperledger special telecom special interest group community. So this is really where we try to see how we can optimize the wholesale intercarrier settlement between network operators with Hyperledger Fabric. So yeah, so we can discuss these further, but yeah, so this is again kind of comparing the legacy OSS and BSS in network operators and how they can benefit from blockchain technology. This is our last slide, really. So these two are really just some of the available opportunities that we have for co-funding of projects in Connect Center. So the first one is the SFI Industry R&D Fellowship Program. So they co-fund and industry fellowships up to 80%, depending on the size of the host company, and also other factors. The other co-funding scheme is internal to Connect. So Connect co-funds projects, targeted funding and platform funding up to 50% from the Connect side. So you can reach out to me or the funding managers in industry managers in Connect Center for more information.